it is now recording. Okay, let's see what you remember from exercise 1A. So last week we tried to zoom through 1A and 1B despite so many issues with internet and my computer lagging. 1A, let's do a revision. What was 1A about? Let's go with Sarush. What was 1A about again? No idea. Is it in your notes? What do we do in 1A? Yeah, that was 1B. So good. So at least you remember there was something. So 1B was to do with domain and range. Okay, but in order to list your domain and range, you had to know something before. That's why 1A was the first thing you had to learn. What was it? Set notations. Set notations and interval notation. That's pretty much the essence of 1A. For those who don't know what that is, you know when you write X element of, say, bracket 2, comma, infinity, open bracket, this is called set notation. Putting together, that's interval notation. Okay, so I'm going to write here, this is set. Oh, sorry, this is interval. This is set. The whole point of 1A is that you can read the notation. Okay, you can read it, then you apply it. That's what 1B was. See, 1B, which is what I wrote here, I'm essentially saying the domain, which in layman terms means all the X values for this particular graph or set of relations or functions can only have the number 2 all the way to infinity. But it can include anything in between. So it could be 2.1, it could be 2.5, it could be a recurring number, it could be an irrational number. That's what I'm saying. Okay, so the language is domain can be from 2 to infinity. I should have wrote inclusive here. Okay, so 1A was about set notation, interval notation. And you had to learn a couple of things like, for example, what was the letter capital N stand for again? Let's go with Leo. Natural numbers. What are natural numbers? Let's go with Jacob. Counting. Beautiful. Natural numbers. Those are the kind of things that you needed to know. I'm not going to go through it all again. So again, N, Z, after integers, you get to rational numbers leading into real numbers. Okay, so just learning the uses of your symbols like union, intersection, backslash means what again? Is that backslash? Sorry. Exclusive. Okay, so you're excluding. Make sure that you're using backslash, although they don't penalize you if you use forward slash now. Back in the past they did. And then there was a symbol that Tig asked. What was this one? Subset. Very good. Subset means it belongs within. So for those who don't understand what that is, subset looks something like this. B is within A, so we say B is a subset of A. So we'd write something like B subset of A. Okay, cool. So that was exercise 1A. 1B was domain and range, plus there was also an extra feature, which links on today's lesson. So one, you have to be able to remember how to sketch your linear graph, quadratic graph, maybe square root functions, and then determine the domain and range. And then there was something else, the second half. What was the second half of the lesson that I mentioned about Krish? So you have to learn domain and range for 1B. What else do you need to know for 1B? Yeah, so the key word here, I'm going to write relation. I'm going to just draw on the side again because some of you may not have remembered this from last year. So relation. What is a relation? Describe that to me. Let's go with Charlie. Very good. I'm just going to say group of coordinates. So XY. So when you've got a bunch of dots on a Cartesian plane, like this, all those coordinates for y-axis and x-axis, a bunch of them together is called a relation. So it's a group of them. But when you have a relation, so a bunch of coordinates that happen to follow a particular pattern, something like this one, then we say it's a linear function. So it's a relation, but this group of coordinates happen to follow something, and then we call it a function. So this is called linear function. And then you might have the graph of, say, something like this. And that also still fits in the definition of a function, so then we call that a quadratic function. But that's a bunch of coordinates. So that's called a relation. That's a relation, but specifically, it's a function. Okay? So think of an umbrella term. Everything's a relation until it fits a definition of a function. So what was the definition of a function? Can I please have Luke? What is a function? Beautiful. And the best way I tried to show you in the notes is that for every x coordinate you put into the function, so whatever that is, that it spits out exactly one y value, not two. As soon as it hits two, it's a relation. Here's the example. Y is a linear called a linear function, and y is a quadratic function, and not quadratic relation. You can see here with quadratics, y equals x squared, that's your function. So if I just picked any number and you chuck it in, doesn't matter which number you think of. So if I put in x equals to -2, the function is x squared. So I'm going to square -2, and the square of -2 gives me y is equal to, Sima? So I'm putting -2 into the function. So I take it -2. Check into this function. Function is an x squared. So if I squared the -2, it gets me 4. It's only one value. So 1x gives me 1y. You can put multiple x's as long as it comes out 1y. That is called a function. That's why these two, no matter which x values you choose, if I choose 2, you get 1 y coordinate. This one's the same. If I pick 2 or -2, you only get 1 y value coming out. That's why it's a function. What's an example that is not a function? Here we go. If I gave you y equals root of x, same idea. Let's draw another box. And if I said, now what is the square root of x equals 9? So if the function was root of x, square root of 9 gives me what? 2 possible answers. Phoenix. Plus minus 3. Beautiful. That's a problem. That's not a function. That's a relation. Yeah. Square root of x is the function, and then x, if x is 9, so it becomes root of 9. And the root of 9 becomes -3 or 3. Is that what you're asking? Yeah. Yes, I'm saying this is the function, which technically I should have replaced that with f of x. But I'm saying, what if x is 9? Because we don't know what x is. If I sub 9 into the function, meaning find out what root of 9 is, root of 9 then can give you either -3 or +3. No. So.
But didn't you say that's the square root relation? Like it's plus or minus?
Yes. Very good. Very good. Okay, so I'm getting what you're saying now. So that square root that I wrote here, that one, because I've given it to you, that technically is a positive root x. So you're right. You're right. When maybe what I should have done, actually, very good. I see what you're saying. So let's clarify that. If I gave you, technically this is what I should have done. Oh, sorry, I should have done it this way. Y, yeah. Y squared equals x. Technically, that's how I should have wrote it. I was just scared I was going to confuse you all, so I just went with the square root part. But yes, from here, when you calculate for y, you would have to root the x. But this here technically is a plus or minus, so hence it becomes what we call a relation. But I was scared that with the notation I'm using could confuse you, so I just went straight to the root part. But you're right. In the exam, if they gave you directly as is, if they just gave you f of x is equal to root of x, that's already telling you that's a positive. It's only when it's the step before they gave you this, then going from here to here, that is technically a plus minus there. Yeah. And so hence this graph, this is called the square root relation. That's a graph of a square root relation, which looks like this. And by the same theory, for an x value, if I chose 9, that's why I get both possible values. I can get a positive 3, negative 3. That is not a function. And that's why a vertical line test, if it crossed twice, that's why vertical line test is used for, is it a function or is it not? Okay, so that was part of exercise 1B. So if I'm saying anything right now that's like, oh, I've forgotten, didn't understand, that's what 1B was. You need to go back and just double check on that, because that's I think we taught that last year as a brief thing, but you need that as a prerequisite knowledge into 1C and 1E, okay, and 1F as well. All right, so that's a recap of A and B. Let's look at C now. Okay, so C, now that you know relation is a set of coordinates, a function means that it has to only have one y coordinate that comes out. How do you test for it? Do a vertical line test. That's the easiest way to figure it out, yeah? But it also means you have to be able to sketch the graphs to visualize that. Let's do 1C now. So I'm going to go back to these notes. So on your notes that I've given out to you, we've got 1C. We'll start from here. Here we go. Exercise 1C. You need to now know the types of relations. Okay, so we said relations is all a bunch of coordinates. There are 4 specific types. Here are your 4. You've got a one-to-one, many-to-one, one-to-many, and then many-to-many. The way I normally try to teach students so that they can remember it is that, same with your coordinate system, x comes first and then y. What this is saying, when you say a one-to-one, so it's like a coordinate system, when you sub in 1x, that's what 1 could represent. So I put in 1x coordinate, I will get 1y coordinate. But one of the things we know, based on the definition of function, as soon as it only has one y coordinate, it's a function. So which of these relations has the y coordinate? There's only one. First one's clearly, it's got a 1 on the y section, so that's a function. So a one-to-one is a function. Which one else? Or which else? Yeah. That's the key. Look for those ones. When you see that, that's implying that one y value is coming out. That's the definition of a function. So if you had to remember it, that's the best way to remember it. One y coordinate. So hence these two, in your notes, that's a function. And the rest is a relation, or the other two we say it's a relation. Well, technically they're all relations, but specifically, number 1, number 2 is a function. To give you a visual image of each one, so one-to-one's easiest function that you currently know. What type of function is a one-to-one? Name me one. Arian. Name me a one-to-one function. Linear graph is a one-to-one, so if I drew a linear, just to help you visualize that. Linear, 1x to 1y. It's only 1 for 1. Yeah, so that's a one-to-one function. What's another one-to-one function? Vibha, give me another one. Y equals 1 on x. So 1 on x looks like this. Okay, so that's a rectangular hyperbole. Again, same thing. Can you see if I choose 1x value, it touches the graph once, and there's only one corresponding y value. That's a one-to-one. Okay, or how do you test for it? Vertical line test. If I just did vertical lines, no matter where I draw, it only intersects once. All of them intersects once. That's a one-to-one. Square root function is a one-to-one. Quadratic function is a not a one-to-one, sorry. So square root function is not a one-to-one. So we can see it is a function, but we're going to prove it's not a one-to-one. Okay? But those two, if that helps you, 1 on x function and then y equals x, these two are examples of a one-to-one. Many-to-one. What's a classic example? Jason, what's a many-to-one function? Give me an example. Quadratic. This is an example of a many-to-one. And what does many mean? It means many x's. You can put multiple x's and it gets the same y value or just one y value. So what's an example of that? Quadratic. Quadratic is one of the best easy ones to remember are many-to-one because you can put x equals -2 or x equals 2 and the y value that spits out, square root of -2 or square root of 2, still gives you the same y value. So if you look at the graph, you can see that. It happens when y is 4. There's only one y value. But how many x's are there? There are 2 x's. That's why we say many x to 1 y. That's what that represents. Okay, so it's a function, but it's many x to 1 y. So classic example, quadratics. Next one. What's an example of 1x? So you put in 1x value, but you get multiple y values. So 1 to many. What's an example? So, yes, it could. It's partially correct. Circles is partially good, depending which circles you choose. Anyone else? I want a classic example so that you remember. I'm trying to give you a visual image. 1 to many. So 1x, you get 2 y values. Square root relation is one of the easiest ones to remember. Okay, so if you put in x equals to 9, and then you square it, and again, going back to that confusion we were saying, just remember, I'm going to write a plus minus here. Okay, so square root of 9 can give you -3 or +3. That's an example. If you had to draw a graph for a 1 to many, looks like that. So 1x, okay, you put 1x, and you can see you get 2 possible y values. So this is a 1 to many.
But can you use the function notation if it's a relation? Like,
No.
can you say,
Because a function notation is for functions, and a relation isn't.
yeah.
So when you use function notation, oh, that's another thing I forgot to revise as well. Function notations in exercise 1B. If you don't know what that is, go back and have a look. Otherwise, I'm going to teach you individually as well. Okay, but function notations is part of 1B. And yes, you only use function notation for functions. Can't do it for relations. Relations, you have to split it up. You have to split it up into 2 pieces of functions. So here we go. That is a 1 to many. And then the last one, which is what Charlie was saying, it was a circle, many to many, because a many to many has both the ideas that for 1x you get 2 y's, but also for 1 y you can get 2 x's as well. That's why it's a many to many. So it's many x's to many y's and vice versa. Okay, whereas a square root relation, specifically 1x to multiple y's. Okay, so here I'm just going to write it again. This one you can have 1x and you end up with multiple y's. So 2 y's, or you can have 2 x's for the 1 y. So 1 y to 2 x's, or 1x to 2 y's. Okay, that's why it's called a many to many. So that's pretty much today's lesson. The lesson is for you to be able to identify what type of relation you have for 1C. So 1C, they'll say identify the relation or justify what type of function it is. You have to be able to tell which ones are 1 to 1, which ones are many to 1, which ones are 1 to many and many to many. Okay? Types of tests to help you remember. So in case this theory is flying over your head, here we go. We already know vertical line test was to test for what again? Function. So the question is it a function? Do a vertical line test. If it crosses twice, not a function. Crosses once, it is a function. Yeah? Then you have the next one, horizontal line test. Horizontal line test. What does it do? What's horizontal line test do? Anyone have a clue? Check if the function is 1 to 1. So remember, once you do a VLT, which is the number one thing to do first, check if it's a function. But once it's a function, it follows on, well, out of these functions, which one is it? And this one tests if it's a 1 to 1 or not. That's why quadratic, if you do a vertical line test, you can see, yes, function. But then when I do a horizontal line test, crosses twice, so we now know which type of function it is. It's a many to 1 because it crosses twice. And it cross once, then we can say 1 to 1. Okay, so I'll draw it a bit neater on this side here so you can see. If we did a linear graph, here's a linear line. First test, vertical line test. Yes, cross once. It's a function. Do a horizontal line test. Crosses once. Definitely 1 to 1. Okay, and you need to know that for exercise 1F. So you need to know, is it a function? And then is it a one-to-one function as well? Okay, so horizontal line test as if it's a one-to-one. Vertical line test as if it's a function or not. But you always do VLT first before HLT. All right. Here we go. Fill in your notes. So is used to test if it's a function or not, one-to-one or not. I've drawn a couple of graphs for you to see. One-to-one, one-to-many, many-to-one, many-to-many. You can write your own notes there just to help you remember. So let's flip over the page. Here we go. All right. Is the aircon on? It's so hot. All right. Implied domain. What does implied domain mean? So we've got domain from 1b. What is implied domain? Let's go with, who haven't I chosen yet? Adonis. What's implied domain? Say it again. Very good. And it's very obvious in that case, but I remember many students ask me this when they see it in a test or so. Implied domain literally means they don't tell you. Who said function notation before? Someone here was, I think it was Sarush. Someone asked about function notation. See, when you write a function notation, it looks something like this. F for function. Then they might do something like 2 to infinity. Maps onto. Like that. That's called a function notation. When you write that, this first interval notation part tells you the domain. That's quite explicit. They actually tell you. But when they don't tell you, for example, this one, there is an implied domain, meaning there is a restriction on this graph that we have not been told, but you're meant to know. Oh, sorry. Thank you. I was so focused on the function. Yes, you're right. There we go. Thank you. Function notation. So domain maps onto the codomain, and then the function is f of x equals x squared. So this one we know the domain. This one, you have to know the graph to visualize or know the limitations of square rooting. What can't you square root? Negative numbers. Okay, you can't square root negative numbers unless you work into complex numbers, which is only for special students. So, because you can't root negative numbers, there's an implied set of numbers that you can take. X can't be any number you like. There is a restriction to it. And the restriction is it can't be negative, but it can be 0, and it can be positive. That's why the graph, when you draw it, it'll look something like this. Starts off at 0. And because of that, there is an implied domain. So if I ask you now, what is the domain? So x is an element of, how would you write the interval notation? What is the domain of this square root function? Let's go with, sorry, I haven't learnt all names. What's your name? An. What's the domain for this function? How would you write it? X element of positive real numbers. So we can say R plus. But what are we missing? R plus is all the positive numbers. What am I missing? 0. So how do I include 0? Union. And you're listing. Remember, when you list, you use curly brackets. 0, close curly brackets. That's one way of writing it. Another way of writing it is close brackets, 0 to infinity, open brackets. Means the same thing. Okay, so we're just writing that first bit. R plus means you can have all the positive numbers, but it doesn't include 0. So you have to write include 0. So you've got 2 sets of notations. This is what they will test in the exam. So they want to know if you know the functions. They want to know if you know the limitations to a function without them telling you. That's called an implied domain. All right. So 1C, you're practicing implied domain. Again, it really draws on, do you know how to sketch your graphs? If you don't know how to do that, use your CAS or Desmos. I want you to sketch it. The whole point of chapter 1 is going back to see if you can work on domain, range, notations. Okay? If you're struggling with sketching from last year, you can learn that slowly. Ideally, I want you to learn that as fast as possible. Okay, you need to know all the graphs from last year, and then we're going to add on a few more. Okay? All right. Let's see how much you know. So let's look at the last two examples here. First one, what type of graph is this? Because obviously I'm revising your year 11 methods. What is this graph? F of x equals 1 on x minus 2 squared. Leo, what type of graph is this? Truncus, very good. So it looks like a tree trunk. This truncus function, and now this is pushing it because this is next chapter. This is chapter 3. What does x minus 2 do? Hands up if you know. Very good. So it changes the asymptote, translates it 2 to the right. So I do expect to have an asymptote for this truncus at x equals 2. And the graph will look roughly like this. Now, I obviously haven't worked out the y-intercepts, but I know there should be a horizontal asymptote as y equals 0. Again, if you can't do that yet, ideally you want to get pretty fast at picking up on how to do that again. Okay, so that's prerequisite from last year. All right, so I've got my graph. I can visualize it now. Now it says determine the implied domain and determine the type of relation. So let's look at the domain then. Let's go with Aryan. What is the domain of this graph that I've drawn for you? Negative infinity to infinity. Good. So from here all the way across, a little bit missing. What am I missing? What can't I have? There's a number that this graph clearly cannot have. Asymptote. Why? Because if you put 2 minus 2, that's 0. What's the problem? 1 divided by 0 squared. You can't do it. You cannot divide by 0. You can do 0 divided by 1, but you can't do it the other way around. So anytime the denominator is 0, it's undefined. That's why x equals 2 will not have a y coordinate. So what's your domain? Your domain is exactly like what Aryan said. And there's many ways to write it. You can write it in what is it called again? The inequality notation, if you prefer that. I think it's better that you get practice into set notation and interval notation. Okay, so how I would have wrote it, I would have done x, element, all numbers. Okay, so I'd say it can be any number you want. But then I realized, no, actually, you can't have 2. So I'd do backslash, excluding 2. That's how I'd write it. But you could write it another way too. You could have done negative infinity up until 2, open brackets, union, open brackets, 2 to infinity. It would have been the same thing. Okay, but I'm trying to get you to use more set notations. Okay? And interval notation. What type of relation is this? What type of relation? Remember, there are 4 types of relation. What type of relation is this? Let's go with Ishan. What type of relation is this? A many to one. So again, to a vertical line test, crosses once. This is the function. The function has only 2 types. It's 1 to 1 or a many to 1. Do a horizontal line test to figure it out. Crosses twice. Because it crosses twice, it's a many to 1. So this is a many to 1. This is the kind of example you're doing in exercise 1C. Take the essence out. Don't try to do all questions. Just learn what I'm trying to tell you to tick off. You have to be able to take these skills and say, do I get it? Good. If you do, move on. Don't laboriously do all the questions. You'll run out of time. Yeah. Next one. Root of 4 minus x squared. What type of graph is this now? Wow. This will test some of you. Semicircle. Okay, well, there's many semicircles. You could have a semicircle up here. You could have a semicircle like this or the left. Which one is it? The first one. So you say this top half? All right. Yes, again, you have to revise your semicircles if you've forgotten it. Another way to remember as well, since it's y, so it tells you all the y values, so you expect it to be in the top half or the bottom half. Okay, so if it's a negative, it'll be on the bottom half. It's currently positive, so it's in the top half. So we know it's a semicircle this way. How did you know it's a circle? That bit. Yes, it has a square root. It looks like a square root function, but square root functions do not have a square there. Okay, that's how you know. So it tells you it's a circle. Or another way to do it, if you rearrange everything, square both sides, you get y squared is equal to 4 minus x squared. Bring the negative x squared across, and that is the definition of a circle with radius of 2. Okay, so that's 4 there, so square root the 4, you know it's a radius of 2. So if I had to draw this, a full circle should have looked something like, that's a very terrible circle I'm drawing there, but it should have looked like this, but because I've rearranged it and we square rooted, and clearly it's a positive root, that's why it's the top half. Okay? Again, you need to revise this from year 11 if you've totally forgotten it. Okay, so it is expected that you look at that and you visualize this. But to start off with, you can use a CAS or Desmos to visualize the graph. All right, I've drawn the graph for you. So it crosses 2, negative 2 to 2. What is the domain of this graph? Can I please have, let's go with Alicia. What's the domain of this semicircle? Beautiful. Negative 2 to 2. How would you write this, Luke? Square brackets, very good. Perfect. Inclusive negative 2 to 2. Use square brackets. It matters. That will penalize you if you use the wrong brackets. And then lastly, type of relation. What type of relation is this, Krish? It is a many to one as well. Same thing again, vertical line test. It's a function. Function has only 2 types, 1 to 1 or many to 1. Horizontal line test crosses twice, so clearly many to 1. How do we feel? Pretty good? Okay, now this last question, I'm going to pause the video. So that's 1C. That's the essence 1C, and then I'm going to write the solutions, but I want you to have a go with this one. How do you find the implied domain? Because you have to also know how to read the equation. Sometimes you can't sketch the graph, but you can analyze an equation. Okay, so ideally I don't want you to type this on a CAS, but if you have to, do so. But I want you to see if you can analyze the restrictions of this graph and logically figure out what is possible, what isn't possible. Okay? I'm going to pause the video, have a go, and then I'm going to give you maybe like a 5-minute breather before we check into 1E. Okay, 1E is a bit tricky, but I'm going to give you a bit of time right now. So you get, say, 7 minutes to have a go with this question, and then I'll give you 5 minutes to just recollect your notes before we get into 1E. Okay, so I'm recording again. All right, this question, example 2, you had a couple of minutes to have a look. Hands up if you got the answer for the implied domain as negative infinity up until 3 inclusive. So you can have a 3. And then union with 4 to infinity. So if you think about a number line, on the number line, I'm essentially saying up to 3 is good, up to 4 is good. So it looks like negative infinity up until 3, and then 4 to infinity. Hands up if you got this answer. Okay, good. Hands up if you used a CAS calculator to visualize the graph. Oh, wow. Oh, that's really good. Okay, so again, for those who didn't get this one right, the skill is sometimes they'll give you a graph in the exam where you can't actually sketch because, say, exam 1, you can't have a CAS calculator. Your skill is to extrapolate what you have. So I can see that x minus 4, I factorize x squared minus 7x plus 12. It's quadratic. I sketched it over here. It's a positive quadratic, so roughly it has an x-intercept of 3 and 4. And then what's my limitation? Quadratics don't have a limitation. Domain can be any number, but there is a limitation to square rooting. You cannot square root negative numbers. So that means whatever this quadratic is, that is going to end up having a number. So you put x in, this will give you a y value. So here's all your y values. When can't you have it, or what can't you square root? It's when the quadratic is negative. Quadratic is negative below the x-axis. So between 3 and 4, that's when the graph, for the quadratic graph, negative. So if I pick, say, number 3.5, if I put 3.5 in here, I'm going to get a negative number, and then you can't square root that negative number. So as long as I don't choose a number between 3 and 4. 3 and 4 is okay, because when it's 3, it's going to be 0. 0 times anything, square root of 0 is okay. That's why I said it's negative between 3 and 4, but not inclusive 3 and 4. So that means you can choose any number, and you can keep square rooting it. Square root the results of the quadratic function, you can square root any number except when it's 3 to 4, the quadratic's negative. You can't square root a negative number. That's why. Okay, so you have to be able to extrapolate them. I can put it into a fraction. I can put it 1 on root x, for example. You have to be able to extrapolate and then determine. That's 1C. Okay, so 1C in the later questions, that's the kind of questions you want to practice and extrapolate. Cool? If you got that, you felt pretty confident, move on. Don't spend your time doing all the questions you already know. Do questions that you think will challenge you to test that essence and understanding. Okay, so 1C, to summarize, you have to learn implied domain and types of relation. So if you know how to determine types of relation and you're pretty confident in finding implied domain, you're done. 1C is done, tick it off, move on to the next exercise. Okay? All right, here we go. We're moving on to 1E now. I'm going to stop